Hello everyone, in today's video we are going to program this impeller using standard multi-axis toolpaths. I prefer working without material rendering option switched on. In the view tab you can switch it off. Now we will create 3D model that will represent our stock and all geometry required for that. Let's save on the new level called, for example, stock model. We will create 3D model using revolve option. To do this we need two things: center line that we will use as a rotation axis and the outside contour. This can be created by pre-selecting 3D model on our screen and then select turn profile option. Now press reselect axis of rotation and select the line we just created. Everything looks okay. Now hit the OK button to accept the settings. And you can see top profile created by Mastercam. Now we have everything we need to create 3D model that we will use in our stock setup. To do it, go to Solid tab, select Revolve option, select Chain to Revolve, OK, select Axis of Rotation, the line that we created 2 steps ago. We can change the name of the model to keep things organized. Hit the OK button and we have Solid ready to use in our stock setup. Of course, first we need to select our milling machine, and for the purpose of the video I'm going to use the default one. Now in our machine group properties we can select our stock setup, switch shape to solid and mesh and select our 3D model we just created. And in levels we can switch off visibility of level with our stock model and switch on visibility of our 3D model that we are going to program. First of all, we are going to rough out the material. We can use one of the 3D toolpaths like OptiRough or Pocket. But today we are going to try new toolpath. It's a multi-axis roughing toolpath called 3+2 automatic roughing. I'm going to save a bookmark. It will let me to go back quickly to the same position so I can work and see my programmed 2 blades and the same section. As you can see, the whole floor of the impeller is created as a single face. I will split that face and work only on the small portion just between the long blades, and then I will translate it around to finish the whole floor. Now in Model Prep tab, select Split Solid Faces, and we are going to use wireframe geometry to split the faces. Select the chain around the floor between 2 longer blades and confirm by clicking OK button. We have 10 identical segments around the impeller. And to help us to identify what part of 3D model we are working on, we're going to change the color of 3 features of our solid: 1 long blade, 1 shorter blade, and separated part of the floor. You can do it in Model Prep tab. Click on Change Face, select the color, click on the face you want to apply the color to, accept. And we're going to do the same with the long and short blades. After that we are going to split this face again. Select Split Solid Faces from Model Prep tab, and this time using Flow Lines V. Cut the face in half horizontally just above the short blade. We will rough the whole model, but I don't want our tool during the roughing to plunge inside the hole or touch the top face of the 3D model. So we are going to create some additional geometry like avoidance geometry. In the surface tab, we have an option to fill holes, which we're going to use. But first, let's create new level, and all additional geometry will go to our new level. Now go to surface tab, press on fill holes option, select the face and drag the cursor to the edge of the hole, and Mastercam will create a surface cap for us. So what we are going to do now is we will check out this new roughen operation. So this is our roughen operation application. In the model geometry page, we select machining geometry. We need to select all the faces we want to machine. Triple click selects the whole model, the whole 3D model. Now we are selecting avoidance geometry. Let's create a new group. Select those two faces, top and the cap we created. By clicking on the color square next to each group, you can change the color. It will ease the representation on the 3D model. Red color in our case represents the avoidance geometry, and green is our machine geometry. On the tool page, you can choose your tool. I'm going to be using 12mm ball nose end mill 150mm long, so I'm going to change the tool length to 150mm. You can set your speeds and feeds on this page. Next page is a holder page. I'm going to use BT4T tool holder P4C50032, and my tool projection is going to be 125mm. On the stock page, I want Mastercam to calculate the toolpath based on the job setup stock. On the main cut pattern page, you can choose the type of the pattern, as offset, parallel or dynamic. Okay, depth step. You have two choices. First one is a constant depth step, and you give depth in millimeters in our case, as we are using metric system. And the second option is number of slices, where you give a total number of depth cuts. I'm gonna use 10mm depths, and on a sub page, depth step, you can set here the depth of your first cut. Maybe when you use a raw material without facing it, you can set your first depth step to maybe 0.5mm or 1mm or something. You can also set your final depth step. First depth step and the final depth step has to be smaller than your constant depth in cut pattern page. In the depth step page, you can also add in this window list of depths you want to cut. If you have, for example, some flats or depths you want to cut, you list them in here. Intermediate slices, you can add cuts between your main depth cuts, and you can choose the strategy to machine after each depth or after the final depth. In the cut pattern page, you have also different cutting methods: standard, zigzag, one way or spiral. You can change the direction for closed cuts, as well as feed rate for conventional cuts when you use zigzag cutting method. You can machine by levels or by regions, and you can choose when you want to machine your intermediate slices. You can set your step over in 3 different ways: maximum step over in millimeter in our case, or scallop height, as well as the percentage of the tool diameter. On the surface quality page, we are going to use default settings. to fit arcs and points distribution. We also leave default setting on the height page. Tool axis control is the page we can quickly go through. We have 3 modes to choose from: automatic, semi-automatic and manual. In automatic, we can set the search angle increment. The maximum value is 90 degrees. You can set maximum stock to leave in millimeters and maximum tilt range in degrees. In the semi-automatic mode, you can additionally add some tool planes, and you can still set your search angle increment, max stock to leave and max tilt range. In the manual mode, you select tool planes you want to use to rough our 3D model. You have line. You can right click on it and select the plane or assign a plane to it. You can click right button and add another line and select different tool plane to rough the material. You have top plane, front plane, side plane. You have isometric. You can select one of the named planes that you created in the plane manager. You can select one of those from the list. You can also select a view based on your graphics view. So you can rotate the model to the angle you want, and what you see on the screen, it will rough the material based on that view. It will update your XYZ rotation for you. Of course, you can add multiple lines. You can rough part from different angles. As well, you can remove lines. We go into select on the top plane and we'll rough the material from the top. More in depth, we will go through this toolpath in different video. On the collision control page, we set all our clearances. We leave it as a default, as well as linking. We will leave as a default. You can set first entry, last exit. On this page, you can also set up default links and clearance area. Also, you can set your distances like feet, rapid, air moves. You have also sub pages where you can set your area links, links between regions and links between slices. We will use default settings for all the links. The roughing page, you can select type of entry, approach moves. We can do helical, ramp, zigzag, profile, or just straight line. On the next page, on the utility page, you can set your transform translate option for this toolpath. You can translate your toolpath around the axis. You can choose the base point, number of steps, as well as rotation angle. I'm not going to change anything on the miscellaneous page. I'm going to leave tip compensation as default. And there are some additional settings that I want to make sure that my plane is top. In our case at the moment, coolant on, and if you want, on the tool page you can add a comment that will appear in your G-code program. All the settings look okay, so I'm going to hit OK button and see how the calculated toolpath looks like. Okay, Oh, I can see that's too many retractions. Let's tweak some parameters. Let's have a look in the cut pattern. Maybe let's take out those intermediate cuts. So I'm going to set the constant depth step to 2.5 mil, and in the roughing depth step, I'm going to switch off the intermediate cuts. As well, I'm going to change the type of the toolpath. I'm going to change it to dynamic. And I'll take my step over a bit smaller. Okay. Let's set it to regions and see now. Shortcut Alt-T will hide the toolpath. Okay, let's create our roughed out stock model. Now Mastercam gives you default name, but you can change it. So even if you forget to type it in, it will always go through the calculation. As an initial stock shape, we will select the stock setup. And on the second page, we highlight the 3+2 automatic roughing operation and click OK. Okay, our stock model looks okay. We do have some unmachined areas underneath the blade, but we are going to rough it out as a next step. So we go into toolpaths, select Morph toolpath, and in the tool page I am going to use 4 mil ball nose. I'm going to change it to 140 overall length. This is the cutter we have in our stock. And feed rate and plunge rate, I'm going to keep the same. And this way it's going to be only one feed in the program, and it's easier to change on the machine during the run. In the holder page, I'm going to use B4 Y4 M18. And the projection set to 115. Stock setup, we're going to use our stock model. In the cut pattern page, we are going to select the curves, and we are going from this edge to this edge on the opposite side of the floor, and we are going to select drive surface between those edges, and I want to leave stock 0.3 millimeter. Let's limit our number of cuts to 10 just now. Should be enough. So it is going to be 10 cuts, 10 passes on the drive surface. We're going to extend trim. Before that, we're going to change the tolerance. We'll change the tolerance to a bit smaller. I will have to speed up generating the toolpath. When you take extend trim, you have a sub page, extend trim, and we're going to go 2 mil over the outside edge and 0.05 millimeter to overlap slightly. And tool axis control, we're going to leave it as it is, as a default, and maybe in the step over calculation we're going to change to exact. In the collision control, we're going to select the hole holder with the tool, and we want the tool to tilt when it hits the drive surface or check surface, and we're going to select the whole 3D model except the drive surface. In linking parameters, we're going to change default links to for small gaps to go direct, and when the gap is smaller than 15 millimeters. Let's set up our clearance area, height to 20, increment height to 20, and entry feed and exit distance to 5 millimeters. And move safety distance, let's set to 15. And next page is roughing. We want to go in 6 depths cuts, and the space between each depth is going to be 4 millimeters. Oh good, maybe in additional settings let's check if the plane is top, that's good, and we can turn on coolant. Okay, I think everything is ready. Let's click OK and generate the toolpath. It should produce, Mastercam should produce cuts only where the material is, as we selected the stock model in our toolpath. So no fresh air cuts and wasting time. Looks good. Reasonable amount of retracts, and the toolpath looks okay. Let's see how it looks with the stock model on. Yes, no fresh air cuts. Good. In the next step, let's go back to our standard view. In the next step, we are going to rough the rest of the material. We just simply copy the Morph toolpath and paste it below, as we have all the settings already done for the last one. We are going to cut pattern only and select new curves and new drives. That should be all. Okay, let's select the edge. Oh, there must be some gap. Let's see the tolerance of chaining. Let's do it slightly smaller. Still doesn't like it. Okay, let's do a trick and we go from the other side. Sometimes it helps. And then we will flip the toolpath. Flip the chain, sorry. Yes, now went through. Let's change the side, direction, and it went through. Okay, select the chain around the small blade, and now we are going to select the chain around the floor of the section between two long blades. Nice. And the dry surface, we are going to select the floor, of course 0.3 stock as on the top part. That's good. And extend trim, we're going to extend start and end 2 mil. as we are going outside the edge. Hit the regen button and let's see our toolpath. Okay, oh good. In this way we have one section of the floor roughed out complete. At the end of the programming we will translate this toolpath around the part. Let's see on the verify how our toolpath looks like. In the tool component I'm going to untick the holder so we can see more, and let's have a look. Looks okay. We are not plunging, we are not hitting any blades. Material between the blades is roughed. I think it's all good. Let's see again how Mastercam is tilting our tool to avoid collision. Okay, let's go to programming. Close the window and we will copy and paste after again. We can name our operation that will appear in the program. Top of impeller floor. Roughen and the lower part of impeller floor, and here we are going to finish short blade, and time to change a few parameters in our short blade morph toolpath. In the cut pattern page, again we need to select new pattern from, pattern to, and drive surface. Okay, change the drive surface offset to 0 as I don't want to leave any stock on drive surfaces. As a pattern from, I'm going to select the top edge of the blade, and pattern to bottom edge of the blade, and then we will select the surfaces between two edges as our drive surface. Done. So pattern from top edge, bottom edge, pattern to. Now we are going to select drive surfaces. Select this guy, highlight this guy, click on every face between pattern from and pattern to, and selection. I also want to extend the start and finish of each pass to mill. Yeah, that's correct. And in the collision control, I'm going to select a few more check surfaces. Reselect the check surfaces. So triple click on the 3D model will highlight the whole model. Then double click on the blade will unselect the blade. Okay, select radii around the blade as a check. Also in the cut pattern, I'm going to choose different way of calculating the step over. This time I want my number of cuts to be calculated based on maximum step over. To do it, in the area field, we need to change the type to full, avoid cuts at exact edges. For now, I'm going to leave maximum step over as 1 mil, and let's regen the toolpath. Oh, so many retractions. Oh, that might be caused by the tool axis control, as we didn't change from the floor. We want the tool to tilt while it's going around the blade. So tool axis control, tilt angle at side of cutting direction. Let's set up to 60. It should fix the problem. Should be very little retractions. Regen the toolpath. And voila, nice. Only few retractions. I'm happy with the result. Okay, copy the last toolpath and paste it at the end, as I want to use the same settings as for the short blade. Call it long blade. Also, we need some additional geometry, as the side of the blade is designed as one solid face, so I cannot select the edge. Select wireframe tab from the menu and click on curve one edge. Select all the edges between the blade and the fillet. Create lines on the bottom edge, and in the wireframe line, select line endpoints and draw a line to connect to edges. It doesn't let me to choose one. Let me just reselect it. I'm sure it didn't draw a line. Let's have a look. Let's select wireframe mode. No, there is no line. Let's select the line from wireframe again and draw a line to connect two edges. We are ready now to modify our toolpath for longer blade. Hit parameters. In the cut patterns, remove the old chains. And we're going to select pattern from as a top edge. And this guy here. Okay, it's from edge to edge. Okay, and as a pattern 2, we're going to change the chaining mode to wireframe and hit OK. Drive surfaces all the faces around the blade between our patterns from 2. And hit end selection, and it's all good here. The settings we're going to leave the same as for the shorter blade. Let's see. Okay, something wrong with our cut pattern. Let's go to advanced option for surface quality page. Is as a sub page of cut pattern, and change the method of step over calculation to approximate and click OK button. Regenerate our dirty operation. Okay, I can see that we have roughing cuts left and we are finishing the blade. this section is already roughed out. So let's go to roughen option and switch off depth cuts, and let's see how our toolpath looks like. Hit the regen button. Okay, we don't have those additional cuts, but you can see that our toolpath is retracting through the shorter blade. So let's see our collision control, and let's make sure that our check surfaces are set properly. So let's go back to parameters. On the collision control page, select check surfaces, and yes, we have the short blade not added to our checks. When we copied the toolpath, we didn't reselect our check surfaces. It should be okay now. Okay, click on end selection, and I'm going to relax tolerance a little bit. Hopefully it will speed up regeneration of the toolpath. Click OK and regen dirty operation, and it's okay now. There is no collision anymore. We can move to next step. What we are going to do now is going to finish the floor between blades. So we are going to copy the roughing toolpath that we used to rough out the floor between the long blades. You can use right click, copy and paste option, or select the toolpath, hold the right mouse button, drag it down over the last op, release the button and select copy after. Change the name, and we can go to parameters to do some alterations to our operation. First, we are going to remove our roughing cuts from this section, from the floor, as the whole floor has already been roughed out. So I'm going to switch off in roughing page, and the tool axis control all is good. Cut patterns, we are going to switch the type of the pattern to full, avoid cuts at exact edges. Some 3D models edges are not very good quality and it will result in retractions. That's why we're trying to avoid cutting on exact edges. Drive surfaces offset to 0, we don't want to leave any stock, and maximum step over to 0.3 millimeters. The method we have to exact, that's okay. Click OK, accept the changes. Regen dirty op, and let's see how it looks like. Good. One entry, one exit, no retractions. All looks good. Let's have a look how the simulation looks like. So we have our one section fully machined. Yes, looks okay. We have some mark on the longer blade, so we are going to fix it, and it doesn't look really good. It doesn't look really good. And we have also multiple retractions. We want just one entry and one exit. So let's have a look. It must be something with our cut pattern. So let's investigate our pattern from, pattern to. Pattern from looks okay. We start and finish at the edge. Okay, let's see our pattern to. Pattern 2 as well starts at the same side, so it must be some missing surface. Yes, there it is. The side of the blade wasn't selected, so that looks good. Let's change it to exact and OK, and let's view our result. Let's hit the regen button and oh, this guy looks okay now. Yeah, we have one entry, one exit, no gaps. Toolpath looks clean. So we have completed one link, like one section complete. We are going to use now toolpath transform. We can use the toolpath transform from the toolpath section, or we can go simply to each multi-axis operation and set up our toolpath transformation direct in each operation. You can go that into utility tab, turn on transform translate. Our axis direction is Z axis, the number of steps is 10, the rotation angle is 360 by 10 is 36 degree, and I'm using exactly the same settings inside each toolpath except 3+2 automatic roughing and each one, and I go to utility page, transform translate, number of steps 10, 36 degree rotation angle. We've got our toolpath transform set in each operation. Let's regen dirty operations and we will run the whole simulation. In the simulator options, we have to change the stock setup from stock model to a solid that we saved on level 2. That's the one. All looks good. Close the window, and in the toolpath tab, let's run the verify simulation. Thank you for watching the video. Don't forget to download the 3D model from the link in the description. If you like the video, hit the like button and subscribe for future videos. More videos to follow soon.